Thomas S. Kuhn, Paradigm Shifts, and the Bible. In 1962, a man named Thomas S. Kuhn published a book called The Structure of Scientific Revolutions. The idea for the book arose when he was studying for his PhD in theoretical physics. He read through the history of science and began to notice that the standard account of that history did not do justice to the complexity of the situation. You see, science is often portrayed as a slow and steady progression from ignorance to knowledge. It's as if you could say that if the sum of scientific knowledge was an enormous hunk of clay, the purpose of science was just to pack on a little bit more so that over time it gets bigger and bigger. Science is often portrayed as something that only gains knowledge but never loses it, as an impartial and objective way to look at the universe, a view that trumps all other views. Kuhn began to realize that what really is the case is far more complicated than this. Kuhn argues that when we talk about what we know in science, we're never dealing with bare facts, where the facts are simply bits of knowledge that have nothing to do with each other. Anytime science deals with facts, there are always some facts that are seen as being more important than others. Certain problems rise to the surface and demand attention, so more time is spent studying them. Before long, those central questions and issues shape the whole process of science. Kuhn calls the result of this a paradigm, which is the overarching way we actually look at the field of inquiry. Paradigms are extremely important, even though they are hard to notice except when compared to other paradigms. One could say that if a scientist is in his or her paradigm like a fish is in water. They are completely dependent on it in every way, but it's so much a part of who they are that they do not even notice it. According to Kuhn, when certain problems are pointed out, whether they are holes in the theory that need to be filled in, or whether they are data which seem to count against a theory, it's not so much the force of the facts that determines how seriously they are taken, but how the paradigm decides what is important and what is not important. The fact of the matter is that no scientific theory is complete. Every one of them has some bits and pieces that it cannot account for. The question is whether these bits and pieces cause real problems or not. Kuhn argues that there are, broadly speaking, two different kinds of science, or different modes of science, and that scientists engage in: normal science and revolutionary science. In normal science, scientists operate within a paradigm received by tradition, such as Newtonian mechanics or quantum theory or Darwinian evolution. The paradigm determines what problems are seen as most important for scientists to work on. In this case, science takes on the character of puzzle solving. The filling out of the periodic table is a great example of this. The paradigm predicted the kinds of elements that we should be able to find, but we only discovered them over a period of many years. People found new elements, but it was because the paradigm told them what to look for. Referring to this finding of new elements to fill out the periodic table, Kuhn says, "Their pursuit was standard project for normal science, and success was an occasion only for congratulations, not for surprise." There are many times when a shortcoming within a scientific theory or paradigm at one point is just a problem to be solved. It's merely a gap in our knowledge that does not mean that the paradigm or the theory is wrong, just incomplete. There are countless examples of difficult pieces of empirical data that turned out to be nothing more than anomalies, little road bumps to be smoothed out, but nothing more. Most scientists can go about their business not worried about the problems that seem to be in their theories, because history shows many of them will simply go away. But what if the problems don't go away? What if the problems aren't just gaps in our knowledge? What if they are actually evident that the paradigm is not only incomplete, but actually wrong? What if, in spite of all the ways that the geocentric view of the universe could deal with problems, it just isn't so? What if the Earth really goes around the sun? Once upon a time, we thought that what made things burn was the presence of something called phlogiston in the object. As it burned, it released this phlogiston into the air, and when it was used up, that object was said to be dephlogisticated. What this meant was that when we burn things, the air gets more and more this phlogiston, and that eventually it has so much of it that it can no longer support burning. Now, of course, we say that air has oxygen, and that when enough has been burned, the fire goes out because there is no more oxygen, not that there's too much phlogiston in the air. The fact of the matter is that some problems with the theory are just anomalies. They will be dealt with through further research. However, other problems are what are known as counter-instances, which means they end up poking a hole through the theory and ultimately falsify it. The question that we need to ask is, how can we tell whether a problem is a counter-instance or merely an anomaly? Since what's at stake is the whole future of science and knowledge in general, this is a question that concerns us deeply. As it turns out, there is no way to decide ahead of time which of these a problem will turn out to be. At first glance, they seem to be the same, just something that doesn't fit nicely into the state of scientific knowledge at the time. The only real difference from one point of view is that anomalies go away, while counterinstances don't. But how can you decide if a problem that has not yet gone away is something that will never go away, or just hasn't been resolved yet, but will be in the future? There's simply no way to tell. To give an example, the orbit of Mercury is constantly rotating around the Sun, and it moves about 43 seconds of arc every 100 years, which isn't much, but it's noticeable. The question was how to account for this in terms of Newtonian astronomy. As the years went by, more and more scientists felt that it could not be so explained. It was not until the 20th century when Albert Einstein formulated his general theory of relativity that it could be explained, but in doing so, the whole way of thinking about space was put on a completely new foundation. So what do we do when we're faced with a problem? We either have to trust our scientific experience over and against our theory, or we have to trust our theory over and against our experience. Now, at first it might seem silly for a scientist to decide to trust their theory over and against their experience. After all, what do we hear all the time? We hear that science is all about trusting our experience of nature and not trusting in any authority outside of that experience. And yet, when we look at history, we find that the overwhelming majority of scientists have done precisely this. Why is this? It's because when problems arise in a scientific theory, history teaches us that they usually go away, usually turn out to be nothing more than anomalies. If every scientist took every problem and treated it as if it were a falsifying counter-instance, they would be so busy looking for new theories that they would never explore the ones they have and never gain the knowledge that is to be had through that exploration. And yet there are times when scientists need to reformulate their whole way of thinking in order to advance to new knowledge. Now you might be wondering, why are we discussing Thomas Kuhn's landmark book in the philosophy of science in the Bible satellite? The reason is that the more I reflect on what I've learned from Kuhn, the more I'm convinced that it has an impact on nearly every area of our lives and the way we think. Over the next 3 days, we're going to be taking a look at a whole bunch of passages from the Bible, many of which have caused people a lot of difficulty. I'm going to encourage you to look at them from what might be a different way than you're used to looking at them, challenging preconceptions, offering new interpretations, etc. What I want you to do is to be open to the idea that as helpful as certain ways of thinking have been in understanding the gospel and how it impacts our lives, we